Today we're going to discuss properties of exponents. More specifically, we're going to dive into the exponential rules about zero and negative exponents. In order to do so, I'm going to ask you to rely on your inductive reasoning. Inductive reasoning is the type of thinking that allows us to pick up on patterns. As mathematicians, that's what we do. We seek to find patterns in the world and use those patterns to make new discoveries or apply them to other situations. So let's look for a pattern. Here are 3 powers of the same base. With each new power, the exponent decreases by 1. Let's evaluate them. 2 cubed is equal to 8, 2 squared is equal to 4, and 2 to the first power, that's equal to 2. If we look for a pattern in the results, we see that each value is 1/2 of the one before it. Using this pattern, we can figure out what 2 to the 0 would be equal to. If we use our inductive reasoning and follow the same pattern, we see that 2 to the 0 is equal to 1. This can come as a surprise for many students when they see this for the first time. I bet many of you believed that 2 to the 0 was equal to 0. It's a common misconception. The fact is, 2 to the 0 is equal to 1. If you're not convinced, you can try evaluating 2 to the 0 with a calculator. Okay, this pattern worked when the base of the power was 2. Let's see what happens when we change the base. Will the pattern still give us the same result? This time the bases are all 3. So 3 cubed is equal to 27, 3 squared equals 9, 3 to the first is 3. When we look at the results, the pattern is slightly different. Instead of one value being half of the one before it, it is 1/3 of the value. This makes sense because the base is 3. If we follow the pattern, we'll see that 3 to the 0 is equal to 1. It worked. In fact, this holds true for any non-zero base. Any number, we'll call it a, raised to the 0 power equals 1. Just to make sure, we'll try one more base. How about a negative base? Negative 4 cubed is equal to negative 64. Negative 4 squared is equal to 16. Negative 4 to the first, that's negative 4. This time, we can progress to the next number in the pattern by dividing the number before it by negative 4. Again, this makes sense. The base is negative 4. If we follow the pattern, negative 4 to the 0 power is still 1. It seems inductive reasoning tells us again that yet another number raised to the 0 power is 1. It works. Now it's time to figure out a rule for negative exponents. Let's go back to our original experiment. If we continue the pattern, let's see what happens. Each time we evaluated the next power, we had to divide the previous value by 2. Moving forward, 1 divided by 2 is 1/2. So 2 to the negative first power equals 1/2. What about 2 to the negative second power? 1/2 divided by 2 is 1/4. Have you made any observations yet? Think about it. Maybe it would be wise to compare the values of the powers with the positive exponents to the values of the powers with the negative exponents. When we compare the values of the powers with positive exponents to the values of the powers with negative exponents, we see that the powers with negative exponents are the reciprocals of the powers with positive exponents. Let's see if this works with a different base. Using our inductive reasoning to follow our pattern from last time, we see that 3 to the negative first power is equal to 1/3, and 3 to the negative second power is equal to 1/9. When we compare these results to the powers with positive exponents, we see that they're reciprocals of one another. So any non-zero base, we'll call it a again, with a negative exponent is the same as the reciprocal of the base raised to the opposite of the original exponent. In other words, a to the negative nth power is equal to 1 over a to the n. Now that you know the exponential rules for zero and negative exponents, take a moment to test your understanding. Let's begin with problems 1 through 4. Pause the video and think about the answer to each problem. Let's see how you did. Number 1, the original problem is 3 to the 0 power. That's 1. Number 2, the quantity of 4x to the 0 power is also 1. For number 3, the original problem is the quantity -7 to the 0 power. Well, anything to the 0 power is 1. What about number 4? What is -7 to the 0 power? If you said 1, you may have forgotten an important fact about the base of a power. Remember, unless a negative is grouped with a number using parentheses, it's not part of the base. The negative should be brought down with your final answer. Let's try 4 more. Pause the video and think about the answer to each problem. Let's check your answers. Number 5, the original problem is 9 to the -1st power. Remember, a negative exponent implies that you are taking the reciprocal of a power with a positive exponent. So 9 to the -1st power is 1/9. That is the reciprocal of 9 to the 1st power. Number 6, the original problem says x to the -7. Again, this is the reciprocal of x to the 7th power. You should have written 1 over x to the 7th. In problem 7, the exponent is in the denominator of a fraction. The original problem is 1 over y to the -3rd power. Again, negative exponents imply that we're working with a reciprocal, so this should be the reciprocal of 1 over y cubed. Well, that would just be y cubed. We don't write the 1 in the denominator. Finally, we look at number 8, 3xy to the -5th. It's important to think about your base. The only part of the problem that is being raised to the -5th power is the y, so that is the only part that we take the reciprocal of. The 3 and the x will stay in the numerator, whereas the y to the -5th, we need to find the reciprocal of y to the 5th, so that gets written down in the denominator. If you struggled with this problem, think of it this way. The 3 was being raised to a 1st power, the x was being raised to the 1st power, and y was being raised to the -5th power. This concludes our video on exponential rules for 0 and negative exponents. Thanks for watching. If you like this video, please remember to like and subscribe. If you have any questions or suggestions for another video, let me know in the comments below.